Okay, thanks for joining us for the Western Wheels Conference. A couple quick things before we begin. If you need a certificate, you'll find the link for that here. You'll need to submit a separate request for each session that you attend, and you should receive your certificate in email within 24 hours of submitting the request. If there are any handouts available, you'll find those there. And if you're interested in learning more about any of the products featured in our sessions, that'll take you to the product page for each one. And if you click request pricing, that'll add it to your wish list. Here we are at the wish list. You can either complete the form and submit it right away, or you can keep browsing around and adding items to it to get one big quote. And you can always get back to your wish list right up here in the top right-hand corner. That's it. I hope you enjoy the session, and we'll see you on the other side.
Hello, and welcome to the 2021 Western Wheels Conference. Today we will be speaking about teaching alternative fuels with the zSpace platform. I'm Nikki Lester, the Executive Director of Career and Technical Education within zSpace. I joined zSpace about 2 years ago, coming from District 49, where I'd spent 8 years as the Career and Technical Education Director. Prior to that, I had also spent 8 years in the same district as a high school instructor. Education was not my first go-around, and I did spend time in industry, both in IT, and I started my career in the U.S. military as a diesel mechanic. So I'm super happy to be here with you today talking about the zSpace platform. So what is zSpace? zSpace is an augmented virtual reality hardware-software platform used for training kindergarten all the way through industry or workforce. In this short clip, you will see an example of what users experience in sitting behind our platform and utilizing the peripherals. In here, please note that the experiences and what the models and what they're viewing actually comes out off of the screen about 2 to 3 inches. And this is what they are manipulating and how they are viewing their environment.
Welcome to the real world of virtual reality on the zSpace platform. What is zSpace? It's a tabletop virtual reality that's transforming education today. zSpace functions as your typical Windows PC until you open the zSpace application, and then the magic really begins. Long story short, zSpace tracks the user's eyewear and stylus in real time, allowing the user to comfortably reach in and interact, move around, dissect, blow up, or change different variables within the environment.
So why zSpace? These are reasons that we feel as though we help engage the user, the student, by engaging and utilizing our platform. Here's an example of 10 reasons to also use or to consider using AR and VR in the classroom. Again, some of these are repetitive in the slide that you just saw previously, like curiosity and wonder or career explorations. This article actually comes from eSchool News. Great read if you're looking at different technology pieces and possibly different ways to utilize those. But here again, 10 reasons to consider using AR and VR in the classroom. Now, as a CTE director with zSpace, this is one of the great things as we integrated zSpace that I knew that it was going to do on my career and technical education side. We have coined a term with the help of Jeremy Bailenson, the founder of the Virtual Human Interaction Lab at Stanford University, called DICE. DICE stands for dangerous, impossible, counterproductive, and/or expensive. So as you see in this clip here, these are some different examples of the various applications that we have to offer. Danger, for instance, blowing up an engine, or as I had walked into a middle school when I first started, there were 30 students that had bandsaws in their hands. If I could create an environment where they were not in danger and remove any of those safety issues, that's a great reason to be able to integrate some of this technology. Impossible. In this clip, you would see also where you could set gravity for different exercises, say in Jupiter or Mars, so physics examples. Counterproductive. Counterproductive in this clip is showing beach erosion and over a 100-year process, what you could do to manipulate or change the outcomes of that beach erosion. Counterproductive, I will also mention some of the dissections that we're doing. Yes, we need to do them as a practical piece, but if you can give students a platform where they can practice and make those mistakes and try over and over again before they actually do the practical instance, that's a great reason to integrate our platform. And then finally, expensive. I oversaw a medical academy when I was a CTE director, and one time we had ordered dissective parts, cow eyes, cow brains, etc. And those parts happened to come in over the weekend and sat on the loading dock. $6,500 worth of parts were now ruined, and my students didn't get to have that experience because it was just a loss that we could not recover from. So on this platform, students or users can sit behind it and they will always have the same experience regardless of the user. Parts don't get broken, things don't go missing, and you always have those applications and things available again within this platform. Other innovative uses where we're already seeing virtual or augmented reality within the workforce. For instance, military, medicine. In medicine, for example, we do have where some of the surgeons have uploaded CT scans within our environment, and they were actually doing a pre-type of surgery in taking apart those conjoined twins within our environment before they did the actual surgery. So what did that do? It allowed the doctors to be able to see and visualize what was going to happen in the surgery that they were going to do. It allowed all users involved to take part and have better confidence in what that process looked like, because they were able to virtually do the process before they went into the practical surgery. So that's just an example of how medicine is using it, but as you can see, there are multiple industries that have already integrated the AR/VR types of technology. I will also mention that as a career and technical education director, we want to make our students as viable to the workforce. And if these types of applications or technologies are already being used, we need to try to give our students that leg up, and if at all possible, being able to offer some of those similar experiences. So augmented and virtual reality for STEM and CTE. This is what we do well. We do offer a full package within the zSpace platform where you have our hardware, and our hardware is necessary in order to be able to run our applications and make that magic happen that you will see here shortly. Software, like I say, we have an app for that. So we have different multiple applications that can serve across the STEM side as well as the career and technical education side. And then educational content. We feel as though we are a full service package where we do have hardware, software, and then we also provide the technical support as well as professional development support, lesson plans, and educational resources so that your instructors or users have a full circle package of feeling supported and having the full piece of the pie per se. So going into the alternative fuels itself, these are applications that are available within the zSpace platform. Alternative fuels bundle means that if you were to integrate our technology, our hardware, and you had our alternative fuels bundle to teach the hybrid and electric, these are the two applications that would come within that bundle. The electric automotive mechanic as well as the hybrid automotive mechanic. And these are examples of just a piece of the application itself. One of the things that I'll mention as to why we brought or looked forward in the alternative fuels type of arena is here we see what's happening within the economic outlook, as well as how the manufacturers are starting to invest in these types of technologies to produce the electric and hybrid vehicles. So, electric automotive mechanic. This one here is to scaffold knowledge through the components and exploration and training on safety, which is really important in this system, and system failures. The components listed within the electrical automotive mechanic: powertrain, power battery, high voltage harness, high voltage distribution box, the vehicle coupler, motor controller, DC-DC, and AC compressor structure. Here's a quick clip on the electric automotive mechanic application.
Welcome to the new VR Electric Automotive Mechanic application by GTAFE on zSpace. Enhancing the already popular automotive package, the new Electric Automotive Mechanic offers modules in electric automotive components and training of the whole electric vehicle. In the electric automotive application, the user will start in the Components module. This module offers 8 different systems to choose from: motor controller, DC-DC, AC compressor, powertrain, high voltage harness, power battery, high voltage distribution box, and vehicle coupler. When selecting a specific system, the user can explore submenus to help with learning concepts. These subcategories allow the user to learn concepts such as the component structure, principle, and practical animations. There are also removal and disassembly activities, as well as installation and assembly activities. Once completed in the Components module, you then will enter in the training of the whole electric vehicle. In this module, the user will enhance their understanding on topics of high voltage and safety and environmental rules, as well as failure simulation training. When ready, the user can take the training examination, which will allow them to document the successes that they had while in these modules. By creating immersive learning experiences, the virtual automotive training apps better prepare students to take industry certifications and join the workforce. For more information, please visit zspace.com.
Just a further breakdown, this is an example of the landing page as you would launch that application. These are the different areas in which you would have to choose from under the component side. There are 2 areas within this application to actually go into: learning about the components and then doing some training on the whole vehicle, which we will talk about shortly. So if I chose one of the high-level areas, such as the power battery, when selecting it, when the user selects it, they then will have a menu that pops up that you see here on the right-hand side. They will be able to experience things like the structure of the entity they chose, the principles, and then they also have some hands-on removal or installation training that they can do within this environment. Here's an example of just how it is going through the battery structure. So in here, the user is using our stylus, clicking on the battery, and then coming up to be able to get into and break down and see the different parts that go into making up that system. Here again, you can take it apart, you can explode it, you can make it translucent, being able to identify each individual part within that particular area that you have chosen. And here, just giving you a couple of examples of how that looks and what can be removed or added in the process of breaking down that particular part or system. Please notice that there is either definitions or vocabulary that is also focused on as the user is walking through and learning more about these particular systems. Coming out of the structure of the principles, you now have some removal or installation training, which is more of your hands-on components within this application. So in here, they do a great job of focusing on the PPE or protective equipment that is necessary in working on these types of systems. And then here, if you go into the disassembly or reassembly, now you have the capabilities to actually have some tools, pick up those tools, have some instructions, and walk through taking apart or assembling the particular system or component. Here again, trying to mimic some of the instances of what you would really see in that wait time for working with the electrical battery. indicating what tools, and again, having the directions as you walk through this particular environment. Now, on this slide here, the user is actually walking through, picking up the tools, understanding based on the instructions of what they're supposed to do. And notice these green lights here for the bolts. Through different ways of scaffolding this learning, we have the capabilities to set it so that they have a direct instruction where they're just a force-fed step by step, then some backing off where they have to learn a little bit more and explore on their own and make some of those decisions, and then finally in an exam mode where they have to do it by memory. If students or users get stuck along the way, and let's say they do not have that very direct instruction, but they're in that scaffolding of where they're trying to learn and memorize. If they get stuck, they do have some supporting help along the way, whereas they can click a hints button to give them that next step or what tool or where to put the tool, for instance, so that they can continue to move forward. Now, within, you do have the ability to take apart, put back together. Within some of the areas, you do also have an animation component where now users get to see, such as like you would do on a cutaway, for instance, being able to see how the operation of that particular component is being ran, as well as having some manipulation buttons to change the environment, such as the power on, braking, acceleration, reverse, neutral, etc. if those instances are necessary to show how that component runs and works. Going into the training of the whole vehicle, as I mentioned earlier, there are two components within the electrical mechanic application. The components of where we were before and learning about the particular instances or the systems within the vehicle, and then how to train on that vehicle itself within the failures of what you will see in troubleshooting. In the training of the whole vehicle, there is also some information on the safety. Particularly when dealing with the electric vehicles, we are knowing that there is a high voltage. Traditionally, we know that vehicles range between 12 and 24 volts for their system of electricity. Within the electric and hybrid vehicles, we know that we see vehicles all the way up to 650 volts. That changes the game, especially for safety when working with students and users and learning how these systems work. So this application does do a great job of walking through some of those safety environments and the things that they need to be aware of specifically with the electric vehicles. So here is an example of just the safety and training for charging, the various ways that you charge an electric vehicle, how to, how not to, all of those things that you see kind of here walking through this short clip. Next, outside of safety, under the training of the whole vehicle, you have failure simulation training. This is actually where you get into the troubleshooting and being able to diagnose and fix whatever problem that the fault is giving you. Here's an example. Here's an example of what this looks like as to walking through one of those. So that was, again, just an example of the user or walking through that particular fault from beginning to end. And I know you didn't see the end, but to finalize that recording, it was able to identify what needed to be replaced, put it on a work order, maintenance checklist, and then finalize, retest, recalibrate, and then that failure would have been done and the exercise would have been completed successfully. Again, just an example of the different failures under that failure simulation that is available for training within the electric vehicle component. Here's an example of the maintenance checklist that is filled out during the process of these trainings. So in here, as you're walking through the failure, it helps you identify the failure, the detection, etc. I like this part of it because it actually shows the documentation of record of what users would have to document if they were working through this process. Finally, the training examination. So prior to, we were looking at the failure itself and walking through that and practicing, identifying, fixing, etc. Now, going into the training examination, you're actually being tested on that as well.
Within the new electric automotive mechanic, here you will see that the training of the whole vehicle does have a training examination. In here, the student is required to put in their name and ID. And then the testing begins with a timed test as well as walking through the failures, failure diagnosis, and maintenance and repair. So this one here, we're going to go ahead and click on the driver's side door to enter the vehicle. And then we have to go ahead and step on the brake and check the dashboard. So we're going to go ahead and turn off the vehicle and go in to check the dashboard. So now we know that the battery check battery light is on, and so we're going to go ahead and exit the dashboard. Now we need to just check the maintenance checklist. After we've done that, now we're going to go ahead and click on the diagnosis. In the diagnosis, we now have to then go ahead and set it up so that we've got the tools and we're walking through being able to diagnose what is actually going on with this failure. So, and in here, we'll walk through and test all of these. And once we're done, we know that it will give us a certificate on how well we did, either satisfactory or unsatisfactory, how long it took us, and what the fault was that we were working on. Thank you.
All right, so that was an example between doing the failure, working through it in a training mode, and then going through it in an examination mode. I will note that within these environments, each environment that you're in, whether it's the failure simulation and just doing the training or the exam mode, there is records that are produced in the outcome so that there is accountability for students. That this creates a PDF that can be sent to the instructor at the end to show either where they got in their training mode or how they did in the exam itself. Here's an example of what the user sees, how they log in, and go ahead and begin that actual testing environment. Again, just another example of the certificate that is received. So that pretty much kind of gives you an overview of the electrical vehicle application. Now we're going to move into the training system for the hybrid vehicle. This here, the purpose is to provide installation and operation guidance for the users of a hybrid vehicle. So before it was strictly electric, this one then focuses on the hybrid. The three components here are working with the engine, the transaxle, and the principles of the powertrain.
Welcome to the new Hybrid Automotive Mechanic application by CTE. In conjunction with the Electric Automotive Mechanic application, and as part of the CTE Automotive Alternative Fuel Bundle, the new Hybrid Automotive Mechanic application offers 3 modules: engine, transaxle, and principles of the powertrain system. The engine and transaxle modules offer structure, principles, disassembly and assembly exercises. The engine principles include the basic working principles of the engine, as well as the VVT-I, variable valve timing intelligence, and Atkinson principles. The principles of the transaxle, you will find transaxle principles, as well as planetary gear mechanism principles. When clicking on the structure module, you will see the first level menu. When the bulb is fully illuminated, you will see the corresponding model in solid view. By clicking on a first level menu, the secondary menu will also be available. With the light bulb fully illuminated, you will see the corresponding model. When the light bulb is half illuminated, the model will be translucent. By the light bulb being fully empty, that model will then disappear. When clicking on the explode button, the model will come apart. When selecting the part with the yellow outline, the entire model is movable. By selecting a model with the green outline, you will be able to pick up that individual part as well as see the part name. To restore the model, you will just click Redo. The principles of disassembly and assembly are similar. Each covers the assembly and disassembly exercises for the engine and transaxle, with 3 different modes that can be used. These modes are the guided, the training, and exam view. Within the principles of the powertrain system module, the users will choose from the overall working principles. This displays the working principles of the powertrain, either engine or transaxle, under different working principles, and the working principles of energy flow, which displays the energy flow and interaction of the powertrain under different working conditions. By creating an immersed learning experience with the virtual automotive training applications, better prepare the students to take industry certifications and join the workforce. For more information, please contact zSpace.com. Thank you.
So moving forward, here's a submenu of everything that's covered within the hybrid application and the areas that it addresses. That was kind of spelled out in the video, but here you can see it listed for you. Here's an example of what the user will see as soon as they enter into the application on the landing page. They have the 3 choices to choose from: the engine, the principles of the powertrain system, or the transaxle. Now, the engine and transaxle are similar in the way that they are driven in the same modules that are available within. The principles of the powertrain system is the one that looks just a little bit different. Here you can see I've clicked on the engine, and within the engine, I've got the structure, the principles, the disassembly and assembly that we saw prior. Again, being able to go in and break down the model itself on the structure, exploding it, seeing the definitions, seeing the vocabulary is what you are doing and learning about these different parts as well as systems. Under the structure itself, again, being able to break it down, making those parts translucent, etc., so that you can do that deeper dive on very specific components or systems themselves. In here, talking about the Atkinson principles, there is kind of a hands-on or interactive activity, I would say, where you are seeing how the actual explosion and combustion is happening. Note that it also gives a definition as to how the principle of this particular component works. Now, the overall disassembly and reassembly. Here you can see that is similar to what we saw in the electric component, where you do have the parts and the tools available. There are instructions at the top, And the user then picks up those tools, and you can see here in green, they know where to put the tool because the part is highlighted. Again, it was quickly mentioned that there is a way to scaffold this learning, and I mentioned that earlier as well, where in a guided type of training mode that you see here, it does, once you set this, it highlights the tool for the user. The place where the tool has to be put turns green, and the instructions are available. This happens throughout the 40 steps within the process. If you scaffold that learning and you went just into the training mode, you now have the directions available. You still have the tools available, but they are no longer highlighted to indicate which tool you have to pick up. You also do not see the green here as you do. It is not green. The user then has to figure out where they are supposed to put the tool on their own. However, if they get stuck, this little button at the bottom is your hints button. So again, if they're on step 29 and they don't remember, they can simply click that and it will help assist them. And then finally, you do have the examination mode where once setting and launching that, you have the tools, you have the capabilities to still pick up and manipulate, but you no longer have the instructions telling you the step-by-step process. It is more of a memory-based test that you do have to walk through. Here is just an example of those different modes. So guidance mode is kind of like your baby bird force-fed mode. Training is scaffolding to be able to get help along the way. And then examination mode is that final, how can you do it and show that you've done it all on your own without the support. In all three of the areas in scaffolding, and this also goes into the electric application as well, here is an example of the outcome or the operating record, which is produced as students or users walk through the process, telling us if it's successful or not. And once the user exports that, it creates a PDF that then can be sent to the instructor for accountability. And again, whether that's in the guided training or obviously exam mode produces an outcome. Now, I mentioned that the engine and transaxle are basically the same, where you have the structure, the principles, the disassembly, and reassembly. The principles of the powertrain system is a little bit different. When clicking on the principles of the powertrain system, here you see the overall working principles as well as the working principles of energy flow that we saw earlier in the video. Here is the experience where it's not necessarily hands-on, but it is interactive, as the user can change they can change what they're seeing or the outcomes at the bottom. So whether they're in drive or neutral or reverse, whether they're accelerating or braking, this will all cause different interactions or for the model to do some different things in the way that it's being viewed based on the button or the parameters chosen. Here's an example of just the energy flow, or clicking on the working principles first, giving you that example of what that looks like, how it begins, how it accelerates, again, changing into drive, and walking through that process. Next, going into the working principles of the energy flow. Here in the hybrid, you can see how the energy is recovered, how it's expended, etc., based on what's happening within the system. So again, great examples of how those practical instances are working. So once we've worked through the electric and hybrid application, here's an example of just some of the various applications that we do have supported within the zSpace platform, both in science as well as career and technical education. So as you can see here, we do have it listed out as to the different applications. Like I said, we have an app for that, as to how that lives and how you would possibly bundle based on what you're offering. And if you've already integrated our technology, these are just some other areas that we have to support along the way if needed. Now here are career and technical education software. These we are broke down by the 12 of the 16 national career clusters that we have some applications that will help support those areas of need. Here your health sciences, advanced manufacturing and skilled trades. So we do have things like robotics and HVAC, electrical controls or your small appliance low voltages with switches, etc. some welding, and then again here on your transportation side. Today we have talked about the electric automotive mechanic as well as the hybrid, but as you notice, we do have our regular gas applications as well that cover within our automotive expert and automotive mechanic. Coming soon within the bundle, and again, this one's set up in a bundle, so if you do have automotive, it does come with all three of these applications, or soon will. The standard 2 are already available, and then soon we have automotive diagnostics. This one will operate in a sense of just like troubleshooting or kind of walking through some of those fault failures that you saw within the electric component. This will kind of mimic this or the electric on that particular instance for the automotive bundle. Now, lastly, as we're kind of finishing this up, I do want to mention that we did just come through, a year of having a pandemic and education doing whatever we could to continue to making steps forward. We do have the capabilities within our platform to also deliver face-to-face instruction, but we can help within that distance or blended learning environment as well. Here's an example of using zSpace in a remote learning, some strategies within the Windows 10 environment, which our systems are built on. So our hardware, our technology, our hardware is, yes, something that you do need because of the integrated cameras. But our hardware is based on a Windows 10 system. And within that Windows 10 system, there is a recording feature so that you can record what you're doing, you or a student. This helps with live presentations, it helps with learning support, and online group presentations. So again, just some particular ways that you can help and strategies for that blended or remote learning if it's necessary that you have to use that. So this brings us to the end of my presentation today. So I do want to say thank you for joining me and hanging in there as we talked about our alternative fuels bundle with our applications on the zSpace platform. If you would like to find out more information, we have a really great website that has tons of robust information on all of our products, our technology, our services, etc. So please feel free to visit zspace.com. And if you have any other questions that could be or need to be addressed to me, please email me at nlester@zspace.com. Thank you for your time today. It has been my pleasure, and enjoy the rest of the 2021 Western Wheels Conference. Thank you.
Okay, that concludes another session of the Western Wheels Conference. A big thanks to our presenters. Don't forget to request your certificate if you need one, and we'll see you around next time.